Johan. Sorry, Sean. So we have got Sean and Johan joining us for this webinar. Sean and Johan, you want to go ahead and introduce yourselves?
Yeah, I go first. Good morning, good afternoon, good evening, depending on where you are. Sean Gores, I'm a technical sales engineer with OpenVPN. Excited to be here. We're going to do some demo on clustering. So pass it to Johan if he would like to add anything.
Hi, I'm Johan, and I'm product manager of Access Server. And if there are any questions that you have, there is a question and answer possibility, and we'll do our best to answer those questions. Thank you.
Great, thank you. Yeah, so there is a Q&A box um, on your display, so you can ask us questions by typing it in there. And then if we don't get to it, we will have some time in the end to answer some of your questions live. So it's our pleasure to present this webinar. It's going to cover a very important feature of Access Server and showcase how it enables Access Server to provide high availability and work and operate at a high scale, as well as result in cost savings. So our agenda today is that we will start with a very quick intro to Access Server, as some of you might be new to it. Then we will explain clustering, show some of the use cases to give you an idea of how it can be used, and provide some examples of cost savings. Then we will hand it over to Sean for a demonstration of clustering in action. And after the demo, we will cover some good to know kind of operational aspects of using clustering. And like I mentioned in the end, we will cover any pending Q&As. So getting started next, going over to introduction of the Access Server. Access Server is a pure play VPN server software that you can run on general computing equipment. So what we have done is we have used the OpenVPN open source project as its core and built a lot of additional functionality around it so that Access Server performs as a business VPN solution. You can run it on various popular Linux distributions as well as on Docker. And it's available as a virtual appliance for Hyper-V and ES6i virtualized environments. And you can find it on many cloud marketplaces such as AWS and Azure, etc., for a quick deployment option. In terms of use cases, the most popular ones are remote access, or some folks call it point-to-site VPN, and also site-to-site. Point-to-site covers a variety of things like, IoT communications, secure internet access, IP address whitelisting for SaaS protections, etc. And it's pretty horizontal amongst all industries. Now, before Access Server provides access to the resources, you can authenticate your users using all these supported authentication mechanisms you see listed here, like SAML and LDAP. And what's unique is you can mix and match these authentication methods. For example, you can authenticate a group of users, let's say contractors, using local authentication. And at the same time, Access Server can authenticate employees using something different, like SAML single sign-on. And after authentication, access server can perform additional checks to check whether they are using an authorized device or whether they are connecting from an authorized IP address, or even perform 2FA checks. And then finally, when authenticated access is granted, uh, there you can configure access control in there all the way up to the user level. And that provides least privilege access to only those destinations that are required and authorized for the authenticated user to use. All this configuration can be done fairly easily using the administration web portal that resides on the access server. And users can also get their profile and connection application, which is called Connect app, by logging into the client web portal, which is also being served directly by the access server. So here's a picture of the Connect app, how it looks like on the side. Um, access server can be configured to use DCO. So OpenVPN DCO, or data channel offload, is a feature that greatly improves performance by offloading data channel or data packet, traffic encryption and decryption to the kernel space. And in terms of pricing, uh, we charge based on the number of simultaneous connections, not based on the number of users. So given your use case, this form of charging based on the number of simultaneous connected connections can be quite economical compared to charging per user or per device. And we also have a free plan, which comes with 2 connections, and you can upgrade the number of connections at any time. It takes into effect immediately, and there's no configuration changes needed after the upgrade. It basically comes into effect immediately. The other 2 points of um, the subscription being shared and the active cluster configuration we'll cover more in depth during this webinar. So moving on to introducing clustering. So what is access server clustering? Simply put, it is a collection of access servers that are working together to appear as one big kind of logical access server to your VPN clients or your remote workers. What I mean by that is, for the user, there is no difference, and the user is unaware of which access server in the cluster it is being connected to. It's the same connection profile and credentials. They work with all the, we call them nodes, all the access server that are part of the cluster. And all of them are actively handling VPN connections. So it's an active configuration. All the access servers are handling connections. And if there is a failure, the Connect app will automatically connect to another of the active access servers in the clusters without treating it as a new connection. So, the user does not need to provide their credentials again, authenticate again. It's just a very brief interruption, and then the connection restarts again. So let's look at this example of how a cluster can be used to provide highly available VPN remote access to private resources in a VPC. So you will notice that instead of one access server, we have three, and they are all communicating with an external database. Next, click. So you the in the cluster setup, the access server configuration files and certificates are all stored in a central database system, such as MySQL, Maria database, or Amazon RDS. And then each access server node connects to the database to access the certificates. So this is what enables the VPN client to connect to any of these nodes with the same client configuration profile. Next. So obviously for a fault tolerant solution, the database needs to be fault tolerant too. And you will deploy the access server nodes in different availability zones, again for fault tolerance. And each of these access server node will be activated using the same subscription license activation key. So all of them will share the available VPN connections from that subscription. What we rely on for load balancing the VPN connection is DNS round robin scheme. So that's what is used to load balance pretty evenly across all the nodes. And of course, when one of the node fails, because of the round robin scheme, the Connect app will try the next IP address in the list and connect to another node in the cluster. So those are the main kind of high level blocks which makes access server clustering happen. Now, let's look at another case here. This is an example of providing secure internet access. So we want to tunnel all the traffic to secure internet gateways located in one East Coast data center and one West Coast data center. Based on which one of these data centers the employee is closest to. We don't want to give employees different connection profiles. So we don't want to give the East Coast employees a different profile from the West Coast employees. We want them to use one connection profile and connect to the closest data centers so that even when they are traveling, it's convenient. So what do we do here? Next. We spread the cluster across both data centers. So all the 6 nodes are configured in a cluster, and all of them are using the same central database. Next. So it's the same same database, which is also in a cluster configuration. So with that, I think we'll transition to Sean for his demo, in which Sean, you want to introduce your demo?
Yes. So what we're going to do, I've already set up a couple of class access server on DigitalOcean, and I've already set up my MySQL also. So we're going to look at a couple of scenarios. First of all, we're going to look at the typical scenario with the access server failing and what happens to the user connection. And then what I'm going to do, I'm going to set up the cluster, and then we're going to test it again. This is just to show you what this whole idea is all about, and then how easy it is to add a node to a cluster or start a cluster, and so on. Let's, we are, I think you can see my screen right now. So let's go ahead. Well, before we start, let's look at the typical settings. We have an access server with a user, and we're going to log in as a user or connect to this access server as a user and see what happens when the access server goes down. We all know what's going to happen, but let's look at it in action very quickly. So as you can see on the screen, I have my access server portal or admin user interface on. I'm going to log in. Let me go ahead and type my password, username and password here, and the password here. We'll go and sign in. So let's look at the user management, user permissions. I have one user here, Robert. I'm going to connect to this access server with Robert's account here. So let me toggle the switch. I have to type the password. This is going to be quick. Here we go. We're connected. Now, on this network, I have a file server, and we're going to ping this file server since we're connected on the network right now. So let me type the address, and here we go. We get in reply back. It's typical. We should get reply back. So now what I'm going to do, let me start this. I'm going to go ahead and stop the VPN services. So let me go back to my access server here, status page, and here we go. We're going to stop the VPN services and confirm stop. Now we don't have connection anymore, so let me go ahead back, look at the command here. As you can see, we're timing out. So again, typical, it was expected. So that's what we're talking about, clustering a group of access server. So in our setup, we're going to have two access servers. You can see the IP addresses. I've already set up my SQL database on DigitalOcean. We can see that here. And then again, I have the file server. I've already set up my DNS records for each of the access servers. So it's going to be ascls.ovnlab.com. It's a DNS round robin setup. It's a most straightforward option, providing users with a single connection address, basically. So again, as you can see on my A records. One more thing I've done here is opening some ports, and these are the ports that we need to open on our access servers. I've already done those to save some time for this webinar, but this is something to keep in mind. So let's go ahead, look at my MySQL information. I need the username, password, and the host, and obviously the database name. So I have all this information here. The very first thing we need to do is basically test and configure and test the connection to our access server. I have two SSH sessions going on to each of my access server, as you can see. So I need to install the MySQL and client library package first. So let me go ahead and type those commands here. By the way, I'm going to show you where to find these instructions and these commands in few minutes. So let me go ahead and paste these commands here, and I'm going to do it on this one as well. And okay, the package is installed. So now one thing that we need to do is we need to connect to our database instance using the MySQL command line tool. In order to use this tool, we need to plug in our username, our host, and the password. So I've already set up that, so I'm just going to paste the command here. Let me make sure everything is okay. So, yep, we got the database, the password, and everything else. Again, you can go back to MySQL and you get this information from here on DigitalOcean. So I got all this information here. Let's go ahead and run the test. It's asking for the password now. So again, let me do a side-by-side window. I think it's easier this way. So I'm going to go ahead and copy my password here, and then paste it in my command prompt here. And here, since we see this message, it means that we have a successful connection. So I'm going to do the same thing on my other access server. So let me move this window here. Again, we're going to paste the MySQL command line tool here, and then the password, copy and paste. And again, I'm getting this message, so I have a successful connection. Now let's go ahead and set up our cluster. So I'm going to go log in to my first access server. Here it is. Expand configuration and cluster is here. Obviously, this is going to be a new cluster. So let's go ahead, toggle this switch here. For the name, I'm just gonna leave the node name as my access server name. It is easier to distinguish it later on when we have cluster in place. So I need the MySQL settings again, such as address, ports, and the username and password. So let's go ahead and get those information. I think I'm gonna do a side-by-side window again. It's easier. Here we go. So first, the host name. Let's go ahead, copy that. Let's go ahead, copy that here and paste it here. And then the MySQL port, here it is. This is the port that we need to use. I'm gonna paste that here again. And then the username is doadmin in my situation here. And then the password. I'm gonna copy the password and paste it. Okay, now let's go ahead and scroll down where it says global cluster client connection endpoint. We're gonna type our host name in this field where it says define a cluster round robin DNS host name. If you remember, I showed you those earlier, so I'm just gonna go ahead and paste that here. Now we wanna make sure that use this DNS host name for this node when creating a cluster is toggled to yes, and we wanna make sure that use this DNS host name for new nodes joining the cluster is toggled to yes as well. Now we're done with this part. Let's go ahead and click on Save Settings. And here we go. It's going to restart the access server and we're going to log back in now. Type username, password, and sign in. And here we go. So we can see our first node in our cluster here. Now we need to add our second access server to this cluster. So let me bring up my second access server. Here we go. Again, we're going to go to configuration. We're going to choose cluster. This is going to be a second access server. So we're going to join an existing cluster. So toggle this switch. Again, the same information. We need the node name, which I'm going to leave it as is right now. Then we need the SQL hostname, port, and username and password. So I'm going to do a side-by-side window, so make it easier. We can see everything. So I need this SQL hostname. Let's go ahead and copy from here. And I'm going to paste it here. The port is going to be 25060. And then the username is doadmin. And then for the password, I'm just going to go ahead, copy the password, and paste it here. Now scroll down to the bottom of the page and click on Save Settings. It's going to take about 30 seconds here, and we're going to type username and password. And let me type the password and click on Sign In. And here we go. We have our cluster, the two nodes in the cluster. We can see both have green lights and everything seems to be okay. So now we're going to go ahead, connect with our user and test our cluster. So I'm going to again connect with Robert. Let's go and toggle the switch, type the password, and here we go. And Robert is connected. So we're going to bring up our command prompt. I'm going to ping the file server again. We can see that we get a reply back because we are connected to our access server. So let's go ahead and fail one of the access servers. Here we can see that there is one connection to our first access server. That's Robert is connected. So I'm going to log into the node, basically, to the access server admin user interface, this one. So click on continue here. And we are switched to the admin user interface of a access server. We can see the one user connected here. So I'm going to stop the VPN services. So once this is a stop, let's confirm that. Now let's look at the command prompt. We can see we got timed out. Robert's still connected. It shows connected, but we got timed out because the access server went back. Here we go. The second access server just came online and we got reconnected. So if I refresh this page, we can see that one user now is connected to our second access server. So this is what we're using for the redundancy. So if I go back to my first access server, continue, we can see the VPN services is stopped. So I can go ahead and start that service if I need to here. So let's go ahead and start that. And then we can see that the connection is going on. Promised earlier, I'm going to show you where to find the instructions and those commands that you need to type to get your SQL connection going on with your access server. So if you go to our website, openvpn.net, click on this magnifier or search and type just cluster. And you're going to see this option, setting up an OpenVPN access server cluster. Just click on that, and then you can see the tutorial here, how to set up an access server cluster. So if you click on this tutorial link, you're going to get a good amount of information step by step, from prerequisites all the way how to configure and manage an active cluster with the admin web UI. This was the end of our demo, so I'm going to hand it back to Rohit. Thank you very much, everyone.
All right, thanks, Sean. So now that we have covered some use cases, we have seen a demo, let's talk about the benefits of clustering. We have already seen how clustering can handle more incoming VPN connections and provide fault tolerance. So let me touch on a few of the other benefits. Horizontal scalability. So what do we mean by that? It's much easier to add another node in the cluster uh, as your needs grow than to upgrade to a new server that has more processing power. So what clustering allows you to do is, as the demand on the service grows, it allows you to keep adding nodes, um, facilitating a more seamless um, way of expanding your solution. And in terms of higher performance and lower costs, what we mean by that is, just like we showed in the use case for secure internet access, it allows you to deploy more distributed nodes, making it easier for you to deploy your servers closer to where your remote users are, increasing performance. And I'll have an example shortly about how we can decrease infrastructure as a service or hardware instance costs. And lastly, even the using the shared subscription, that has potential for some savings too, which I'm going to cover next. So here's an example of how pooling of connections saves you money, or at least has the potential to save you money. So because you don't need to buy a subscription for each server, and you can buy one subscription with a larger quantity of connections and share it with all access servers. So buying larger quantities of connections means that you can make use of volume discounts. So a couple of examples I've shown here is, instead of running two access servers each using a 5 connection subscription, which would cost you $140 per month, you can run two access servers and share a 10 connection subscription, which will run to about $90 a month. And similarly, you see our volume discount coming into effect as you increase the number of subscribed connections for from $7 per connection, it gets reduced to $5.65 per connection for 200 connections. And next, here's an example of uh, cost advantages by using horizontal scaling. So here we are comparing two scenarios for deploying a cluster to support 50 connections to a AWS VPC. So in scenario one, we are going for a one-to-one redundancy using two of the recommended M4 large AWS instance type. So each can handle 50 connections. And if you use two of them, it comes to about 20 cents per hour. Whereas in scenario two, we go for one-to-n redundancy using five instead of two, five T2 small instances. And each of these instances can comfortably handle 10 connections. So the cost of this configuration is around 12 cents per hour. So it turns out to be a cost saving of about $60 per month using five servers. And all of these five servers will be better utilized compared to the two servers being used in scenario one. So this is how clustering enables you to also save on your infrastructure costs.
Rohit,
Yes.
I just want to add, just in case people are wondering, those scenarios, I mean, one of them mentioned an M4 large with 50 connections. M4 large can support more connections than that, but it's very highly dependent on what kind of traffic you send through. I just don't want people to think like, wow, an M4 large can only handle 50 connections. No, way more. So this is just a scenario to showcase, the possibilities.
Right, right. Thanks for pointing that out, Johan. So just like I said, it's like comfortably handling 50 connections, but that's the recommended instance type on our marketplace. If you select the 50 uh, uh, tiered listing. So what I want to show is that um, how you can use smaller or lower processing power instance types and use more of them to gain an advantage and cost saving here. Um, okay, finally, I just want to cover some quick points for operating your cluster. One is that all the nodes that uh, are part of the cluster need to run the same version of Access Server, and that the clustering feature was supported in Access Server starting version 2.7.3, which is quite a while back. But that's 2.7.3 and newer support clustering. The other thing to remember is that the first Access Server that you use to create your cluster is the master data that all your other nodes will use. So when you add another Access Server to the cluster, if there are any users or configuration present, it does not mean that those users and certificates will get appended to the central database. It means that uh, the other node that you added will use whatever is present in there from when you from that first Access Server, which is the which creates that uh, master data for that external database. Next to note is that each node has their own VPN client subnet. So if you are relying on inter-device communication, that won't work across the cluster. So if a device is connected to node A, it cannot communicate to another device communicating connected to node B. And we do get asked if instead of using DNS load balancing, uh, 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 we can front end the Access Server cluster using a traditional load balancer, like an elastic load balancer from AWS or something like that. And our response is that no, that's not recommended, um, because while these load balancers may be very good at load balancing web sessions, they don't fare as well with OpenVPN connections, and you also get forced to using TCP. So we recommend using DNS. DNS, can be set up to do some wonderful things, like in the secure internet example I showed. It can be used to determine the closest data center or the closest node based on your geo proximity and things like that. So um, that's what we recommend. And lastly, because all these connections are being shared, if you are using the same subscription activation key uh, among all your cluster nodes, you may want to control the number of subscriptions a bit uh, more stringently. For example, let's say in that scenario, for secure internet access, if there's a data center in the West Coast and there's a data center in the East Coast, and all those nodes are sharing the same connection, and you know that you have more employees in the West Coast uh, than in the East Coast, so you can put a limit on the nodes in the East Coast to only use a set number of connections from that entire pooled number of connections. Uh, and you can find the instructions on our website. It's a SAC-like command that you need to use, and that way, um, the number of connections being served by the East Coast data center won't exceed or won't um, take up connections from the West Coast data center. So,
Rohit, can
yes,
I add something interesting here?
sure.
So the first access server you use to create your cluster is the master data set, and that's correct. This also means you can begin with a standalone setup, and you can start to add your users and configure things. And if at some point in the future you run into a situation where you need more bandwidth, more processing power, and you want to scale up by promoting it to a cluster, that's totally possible. You can convert an existing standalone setup, including all the settings and the users and so on, and you can promote that to a cluster and then start adding nodes. So that is an interesting, consequence of how this works. So if you ever have doubts, like should I start with a cluster or not, start with standalone first. You can always scale it up.
All right, thanks, Johan. Anything else, Johan, you want to add? We are at the end of our webinar. Anything you want to mention about the questions you received? Provide any clarifications to those questions?
Yeah, there's two things. So at one point you mentioned that network load balancer might force you to use TCP, and we kind of quickly glossed over why that is important. Um, when you use programs that use TCP and you then wrap that into a protocol like OpenVPN and transport that also over TCP, so you get TCP within TCP, then any network interruptions can cause something called TCP meltdown, which means your connection will not be as great as it can be. And we avoid that by using UDP for the OpenVPN tunnel. And in this scenario, this is all completely reliable and the best solution. So try to avoid network load balancers. And one other thing is, one of the questions was, can you use a single subscription for multiple instances of Access Server that aren't clustered? And the answer is yes. Our subscription system doesn't really make a difference in regards to whether it's standalone or clustering. You can even have a standalone installation and later promote that to a cluster, and the same subscription will work. You can even have multiple standalone installations using the same subscription. That's also supported. And you can even mix. Like you can have a standalone Access server using the same subscription as your cluster setup does. So that all works. They just pull connections from the pool. I think that's about it.
All right. Any more questions coming in?
I haven't seen any yet, but if people
Okay.
do have any questions, feel free to contact us or ask now.
Yeah, we'll wait for 2 minutes to see if any questions come in. If not, people can drop. Thank you all for attending.